Today's target will be characteristics of linear equations. By the end of today's lesson, you will be able to identify the following characteristics: the x and y intercepts, the zero of the equation, and the domain and range of the equation. So let's start with a linear equation here. This is the equation y equals 1/2 x plus 2. So we're going to start with the zeros, the x-intercept, and the y-intercept. The zero, or in this case there's only one zero, so we don't need the s. But the zeros of the equation are the x values, or x value, that when you plug it into the equation, makes y equal to 0. So we're going to think about what value of x can we plug into that equation and get a y value of 0. We're going to come back to that one because the 0 and the x-intercept are very closely related. The x-intercept is the point where the graph crosses the x-axis. So we look at our graph and say, okay, what point does it cross the x-axis? And this would be the point. The key here is that it has to be a point, which means it needs to be written as an ordered pair. So the x-intercept here is -4, 0. The only difference between the 0 and the x-intercept is the way that it's written. Because the definition of a 0 is the x value that when you plug it into the equation gives you a y value of 0. Well, we get a y value of 0 wherever the graph crosses the x-axis. So the x-intercept and the 0 are always going to be the same, except that the x-intercept is written as a pair, an ordered pair, or a point, whereas the 0 is simply written as x equals. So in this case, x equals -4 should be the exact same value in your x-intercept. The y-intercept is the point where the graph crosses the y-axis. So in this case, looking at this point, which would be 0, 2. Once again, it's a point, so it needs to be written as an ordered pair. So we wouldn't write it as y equals 2, we'd write it as 0, 2. So both the x-intercept and the y-intercept are similar in that they must be written as a point or an ordered pair. And the 0 and the x-intercept are similar in that they have the same value in both answers. Those are our first three characteristics. Our second two are domain and range. Domain refers to all possible x values, and the range refers to all possible y values. So when we look at a graph, we want to keep in mind that the y-axis or y values run up and down, and the x-axis or x values run left and right. So the first thing we want to do is identify what direction are the arrows pointing. Remember, the arrows mean that this line goes on forever in both directions, or whatever directions the arrows are pointing. So in this case, we have an arrow that's pointing up and right. And then we have an arrow that's pointing down and left. So if we start with our domain for this graph, we have an arrow going to the right forever, and we have an arrow going to the left forever, which means that the x values could be all possible numbers. So we could write it out as all real numbers, or as you'll more often see it written, is X, E, R. And what that's short for is X is an element of the real number set. Or in other words, X can be any real number. The range is the Y values, which means we're looking up and down. We've got an arrow going up, and we have an arrow going down, which means that just like the domain, the range, or the Y values, can be all real numbers. So once again, domain, we're looking left and right. So if we have an arrow going to the left and an arrow going to the right, the domain is all real numbers. And if we have an arrow going up and an arrow going down, then the range is all real numbers. Most graphs that you see in this unit will have a domain and a range that's all real numbers. However, you will see a few, like these next two, that are unique and will have a domain and or range that is not all real numbers. So if we look at our second example, we want to look at those arrows. So we notice we have an arrow here that's moving to the left and an arrow here that's moving to the right. These arrows are not pointing up or down, strictly left and strictly right. What that does mean is that our domain is all real numbers because we have an arrow going left and we have an arrow going right forever. Our range, however, is not all real numbers because we do not have an arrow going up, we do not have an arrow going down. Remember that range can be all possible Y values. So if we look at this line, every point on this line has the same Y value. It doesn't matter what point we pick. They have different X values, but they all have the same Y value. So this point is -5, 7, and then we have 1, 7, and then we have 6, 7. Different X values. X values can be anything in the world. The Y values are always 7. We see a similar thing happen in our final example, where we have an arrow going up and an arrow going down, which means our range is all real numbers. So Y can be any number. But in this case, all of our X values are the same. So any point we pick will have an X value of -4. So in this case, our domain is not all real numbers. Our domain can only take a value of -4. So to recap, domain and range, what we're looking at is the arrows. What is the graph doing as it goes on forever? Is it going up and down? Is it going left and right? Okay? So based off of that tells you what's going to be all real numbers and what might not be. As always, if you have questions, go back and review the video. If you still can't answer those questions, make sure you write them down, and you can get your questions answered the next time that I see you in class.